Good morning. We present to your attention the results of research devoted to iron ore underground mining under the internal overburden dump at the PJSC northern GZK. Hanovsk deposit of ferruginous quartzites has been mined by open pit methods since 1963. The depth of the open pit reaches 252 meter, the lower mark of the mining horizon is -120 meter. The deposit is explored in detail to the depth of 300 meter in the central and northern parts and 500 meter in the southern part. Deterioration of mining conditions at mining deposits by open pit methods, increased mining depths, reduced ore deposit thickness as well as increased energy consumption, results in a decrease in working site parameters, an increase in angles of an operating pit wall and deactivation of the considerable part of the open pit due to the internal overburden dump building. Reactivation of the open pit reserves after completion of another stage of mining leads to a surge of stripping and deterioration of engineering and economic indicators. Depending on the location of mine and open pit fields within the deposit, three characteristic schemes can be distinguished. With a combination of vertical operations, underground mining operations, UMO, are performed under the open pit. With a combination of horizontal operations, UMO are in the open pit wall. With a partial combination in both vertical and horizontal directions. Determination of parameters of mining operations when applying the combined open pit underground mining methods possesses certain specific features. They include the final depth of the pit, the open tier, OT, the boundary of transition from open pit to underground operations, the open pit underground tier, out, the beginning of underground operations, the underground tier, UT. In underground and combined open pit underground mining at Hanovsk deposit beyond the contours of the OPMO stage, several technological schemes can be used within the design contours of the open pit. They differ in mining methods, loading, transporting the ore mass onto the surface. Thus, the scheme, see Figure A, provides for application of a system with bulk ore and country rocks caving, loading ore from the block into underground minecars by vibrofaders and ore hoisting in a vertical shaft. The scheme, see Figure B, is distinguished by the method of transporting the rock mass from the stope to the shaft, underground trucks. Traditional technological solutions, Figure A and Figure B, require building permanent ore hoisters and auxiliary ventilation shafts with appropriate surface complexes, transport, and other communications, which is economically and organizationally impractical. The most successful solution to the problem of combined open-pit underground mining of Hanovsk deposit involves low-cost technological schemes. Their options, most suitable for these conditions, are presented in C, D, E. These schemes involve various combinations of the following elements of the technology, of mining reserves, of ore transportation and loading, of ore transporting and hoisting onto the surface. At underground mines, when using high-performance self-propelled equipment, selection of a rational scheme of opening and preparation gains crucial significance for achieving the best results in terms of capital and operating costs reduction. Application of self-propelled machines leads to a change in traditional opening schemes and conditions important features of deposit preparation. At the current level of mechanization, engineering indicators of underground production will be almost similar to those at OPMO. It is advisable to start mining from the southern flank of the site northwards. The transport at it is driven from the level -120 meter, and the ventilation at it, from the level -20 meter in the hanging wall of the deposit. General technical and economic data is given in table. The suggested complexes of inclined and horizontal workings ensure efficient operation of self-propelled equipment and increase productivity of the mining enterprise to 3 million tons per year. Based on the calculations performed, it is advisable to apply the following combination of transport equipment: 6 MT trucks and 3 ST load haul units. When applying the combined method to mine reserves under the bottom of Hanovsky open pit by underground methods, the cost of production will decrease by $3.11 per ton, of which $0.26 per ton are specific capital investments for underground mining. The total amount of capital expenditures will amount to $16.4 million. Thanks for your attention.